Hello, my name is Vasil Ivanov, and this is a video demonstration of how I completed my my lab project for my final project report for CST605. And for this project, I chose Wireshark TCP v8.0. And during this live demonstration, I'm going to show you how I downloaded Wireshark, how I navigated through it, and also how I answered the questions in the lab. So I'm going to go on Google and look for wireshark.org. From here, we press download and download the Windows installer. So for the purpose of the project, I'm going to uninstall the current Wireshark I have on my computer and install it again. We give permission. It asks us to uninstall it. I'm going to say yes. We agree to the rules. We create a desktop icon as well. USB PCAP is already installed on my computer. That's why we're unable to install it again. And we install it. And while it's installing, so this lab contained 13 TCP questions regarding a trace file first that I obtained, live, and then I used the trace file from the lab, and I answered the questions in section 3 and 4 based on the trace file provided in the lab. So once the installation is complete, we're going to press next and finish, and we're going to go back on our lab. So the first section is capturing a bulk TCP transfer from my computer to a remote server. And for the purpose of this section, we're going to have to go on this hyperlink and then download the text file, which we're going to have to upload here on the second hyperlink. First, I'm going to download the text file. Right click on the website, save as, and we will save the file as Alice. We save it. We already have it on the desktop, so we replace the previous one. And then we're going to go on the second hyperlink where we're going to upload the file we just downloaded. We press choose a file, and we put the text we put the text file Alice here. So before we begin capturing the trace, we are going to go on Wireshark, and this is how the front page looks, and we'll go on Wi-Fi because we're going to capture the trace online. And once we go on Wi-Fi, you start automatically capturing packets, you see. However, we're going to pause it from this red square right here, and before we upload the file, we'll start capturing packets one more time. So we press the fin and continue without saving. So once I press continue without saving, it will automatically start capturing packets. I'll go back on the website and upload the file. So continue without saving, upload the file, and then pause it. So now we got the congratulations window that we've transferred a copy of the file from my computer to this web address, and we're going to filter it by TCP. Then we're going to scroll down and look at row 31. So now I'm going to go on on analyze and disable the HTTP protocols. They already unchecked, so that is good. We're going to check it and press enter. And looking at row 31, I'm going to go on question 1 and 2 from section 2. Question 1 and 2 are asking for the IP address of the client computer, which is my source, my computer, and as well as the port number. Then in question 2, we have to find the IP address of the website and the port number we're sending it to. So once we go back, if we look at packet 31, we can see that our IP address is 10.3.167.5, and our port number is found in the transmission in this layer right here, and we can see our source port, which is 62725. Next, we go on packet number 32. I'm sorry. Next, we go on packet 42, and that's where we received an answer back from the website. And the IP address of the website is 128.119.245.12. And as we can see, the port number is 80. This is the HTTP port number. Okay, so going to the third question. The third question is asking for what is the IP address and TCP port number used by your client computer to transfer the file. We already answered this question, so we will scroll down to the third section. So the third section is TCP basics, and for TCP basics, I'm going to be using a trace file I downloaded from the lab. It was a zip file that I unzipped on my desktop, and I'm going to be running this the TCP trace file on Wireshark to be completing the tasks. Once I downloaded the zip file, I made a folder on my desktop with all of the trace files that they have provided us. And in order to run the trace file, we'll go on File, then press Open, then go on my folder, which I named Wireshark Trace Files, and look for the TCP trace file. We open it, and we don't need the previous capture, so continue without saving. And that is how we got to that's how we opened the trace file for TCP for this specific lab. Going back to question 4, they're asking what is the sequence number of the TCP SYN segment that is used to initiate the TCP connection between computer and the website. So to answer this question, we'll go on row number 1, and then we'll go at the sequence number, which is right here. And this is how we find the sequence number of the TCP SYN segment, which is the first packet sent from our source to the website. And as we can see, the next one is this same packet, which was acknowledged right after, and it's a response from the website. Next question is question number 5, and they're asking the sequence number of the acknowledged packet. We can go back, and this is packet number 2, which was the acknowledged one, and the sequence number is right here again, and the acknowledgement number is right below it, which is number 1. Going on to the next question is, what is the sequence number of the TCP segment containing the HTTP post command? Now, what we're going to do is go on the packets, and we're going to have to look in detail in this Wireshark window right here on the bottom left, and to see where the post command is. So on the first one, on the first packet, there isn't a post command. Second one, neither. And the third one, there isn't one. On the fourth one, as we can see right here, we can see the post command, and we are required to find the sequence number of the post command. So once we press on packet 4, we will look at the sequence number right here. So the sequence number is this number right here on this row. Okay, moving next to the to question number 7. Consider the TCP segment containing the HTTP post as the first segment in the TCP connection. What are the sequence numbers of the first 6 segments in the TCP connection? At what time was each segment sent? When was the acknowledgement for each segment received? So pretty much in this question, we're going to have to calculate the estimated round trip time. And going back on Wireshark, we're going to have to locate the first 6 segments. So the first 6 segments are 4, 5, 7, 8, 10, and 11, because as you can see, all of these packets are coming from our source. Then the next step, we're going to have to locate the acknowledgement segments, which are 6, 9, 12, 14, 15, and 16. These are 6. So these are coming back from the website as an acknowledgement of our request. Then we're going to have to pretty much get the time from the first packet and subtract it from the time that it was acknowledged. So for example, the first segment is 4. The time it was acknowledged was at 6. So therefore, we will have to subtract this number from this number. And now I'm going to do the calculation here. I'm going to leave it on the right side so that I can look at the numbers as well. So segment 1, I'm going to put it in bold. Sequence number is 1. Is 1. Then we have the time sent. So the time sent, I'm going to use the digits after the decimal point. So it will be 0.596858. And then we have the acknowledgement received, which is, as I mentioned, the first packet that we got from the server acknowledging that it received the packet. The time is 6249 625.4318. And then the round trip time is estimated to be we have to calculate the 624318 minus 0.596858, which equals to, I'm going to use a calculator really quick. 624318 minus 596858, which equals to 0.02746. So this is the round trip time. Now in the question, they're asking us for the estimated round trip time, which has a formula. This formula I found in chapter 3, and the formula is estimated round trip time equals to 0.875 times the estimated round trip time plus 0.125 times the sample RT round trip time. So then for the estimated round trip time, because this is the first segment, is going to be the same as the RTT we calculated, which is 0.02746. And now we, of course, we expect the next packet to be acknowledged for the same amount of time. However, this is not the case, and now we're going to see what is the case in our example. Now we have segment number 2, and I'm going to bold this, and then we have a sequence number. We have packet number 5, which is the second one. I'm sorry, number 5, and the sequence number is right here, 566. Sequence number is 566. The time sent is, we're going to use the time after the decimal point, as I mentioned, is 612118. Acknowledgement received is the second answer we get from the website, which is packet number 9. Acknowledgement received is 0.647675, and we calculate the RTT the same way. We take the acknowledgement received minus the time sent, which equals to 0.0355557. Next, we have the estimated RTT. I'm going to copy this over. We have the estimated RTT, which is 0.875 times the estimated RTT. So for the estimated RTT, we are going to use the RTT that we had from the previous packet. So this is the time we normally expect, and that is why I believe the formula is multiplying it by a higher number, and then we have to multiply it by the sample RTT, which is the number we just calculated, which is this number. So I'm going to copy it down right here, 0.125 times this number, and here we have 0.875 times this number. So calculating this, we get that the estimated RTT for the second segment is 0.028472. And then we do the same thing for the third segment. But for the sake of time, I'm going to paste the calculated segments right here. As you can see, these segments I already calculated them before so that I can have time for the other questions. But as you can see, for the estimated RTT in the next segment, we used the previously calculated RTT, the previously calculated estimated RTT in the formula right here, and then we sum it up by the multiplication of 0.125 times the sample RTT, which we calculated right here, which is the acknowledgement received minus the time sent. Next question is what is the length of each of the first TCP segments? So how we're going to do that is we're going to go back on Wireshark, and then as we said, packet number 4 is the first segment. Right here on the right, we have the length. So also this length could be found if we go down. The length is found right here, which is 500. This is in the TCP control protocol. Right here, we scroll down, and in data, we have the size of the segment. So first segment is 565. Second segment, which is right here, is 1460. The next segment is for 1460, and yeah, all of the next five packets are 460. Next question is question number 9. And what is the minimum amount of available buffer space advertised at the receive for the entire trace? Does the lack of receiver buffer space ever throttle the sender? So once we go on the first packet that was acknowledged, which is right here, as we can see, this comes from the website. We'll go with the calculated window size. And calculated window size is 6,780. So this amount is the minimum amount of available buffer space advertised at the received segment. And also to answer the rest of the question, the lack of receiver, so the lack of the receiver buffer never throws the sender. So this would not be an issue. Next question is, are there any retransmitted segments in the trace file? What did you check for in order to answer this question? So for this question, we're going to have to create a graph, which is created once we go on statistics. We'll go down TCP stream graphs and then find the time sequence by Stevens. And we'll get this graph. However, this is not a correct graph. We're going to have to switch directions like this. And now we can see our graph and have a better visuals of how the packets were, how the segments were transmitted. So on this graph, we can conclude that there are no retransmitted segments, because as you can see, it's a uniform graph and no segments were retransmitted. So question 11 is, how much data does the receiver typically acknowledge in an ACK? Can you identify cases where the receiver is ACKing every other received segment? So for this specific question, we're going to have to go back on the capture packets, and we're going to look for packets with different size. So we're going to find the common size and then the common data size, and then we're going to find what where the difference is. So typically, as we can see, the receiver acknowledges for 1460 bytes in an ACK. This is an ACK, and we're going to have to identify packets that are different. This is the first packet that is different. The length is 565, and this packet as well, 1147. If we go down, we can find more different, but the most common one is 1460. Question 12, what is the throughput for the TCP connection? Explain how you calculated this value. So for the throughput, we're going to have to find the size of the file. We're going to have to find the size of the, in this case, I'm going to use the trace file because I do not have the, because I use the labs provided file, and then I'm going to create a graph. Actually, we're going to use the same graph that we created for the sequence number right here, and on the graph we're going to find the last packet that was acknowledged, which is right here on the top, and then look at the seconds when it was received. I cannot go down to show you. However, if you look right under right under the graph, it says click to select packet 206, and right next to it there's the seconds. There's the seconds. So this is the time when the last packet was acknowledged. So we're going to use this time 5.651. Next, we're going to look at the trace file. Go to Wireshark trace files, find the TCP, go on properties, and get the size of it. We take this size and take this divided by I'm going to have to create another one because I wanted to see the time it took. 5.651 divided by 5.651. And if you give me 1 second to calculate it, and once we calculate it, we get that the throughput is 32,079.81, and this is bytes per second. Scrolling down, the last question we're going to have is question 13, and we are going to create time sequence graph by Stevens, and we have to identify the slow start, when the slow start begins and ends, and where congestion avoidance takes control. Going back, we're going to use the same one, and I'm using my scroll to zoom in, and as we can see, the TCP the TCP slow start begins at approximately 0.02648. As you can see, this is a slow start, and after that we have a regular packet transfer, and the congestion avoidance takes control right here. As we can see, this is the last packet in this sequence, and then congestion avoidance begins. And this is a really good visual and how we can see where the congestion avoidance takes over. So congestion avoidance begins here, 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 and so on. So this was the last question on my for my lab, and I believe this project was really really helpful for me to learn how to navigate through Wireshark, and I was able to learn a lot more about TCP. And what surprised me a lot was that it's a lot happening. It's a lot more happening than what we see. So it was interesting thing to learn, and I'm going to continue researching and working on Wireshark to learn more information, because I find this really, really interesting. And thank you for your attention, and hope you have a great day.